Morning, guys. So welcome back from break. Yesterday we didn't have a video, so this is the first one of the new year. I wanted to address a couple things to start off with. One question I've been getting a lot of is whether or not we have finals and what's going on with them. Do we have to be in person? So on and so forth. So here's what has been told so far. Tomorrow I should know more information, but this is what has been spread around the rumor mill. Finals are traditionally 15% of your grade. Uh, People strongly believe that finals are an essential part of your course experience. And they feel that there needs to be some sort of final for every class because how else could you possibly know what you've learned unless there is some huge test at the end of the year? So I am not one of them. I do not believe that. So I just want to go over again what my idea of the final will be and also the expectations that will be put on you guys. So first, what I want the final to be is I want it to be a virtual walkthrough. We've all been collecting information. The majority of us have finished our experiment. They've modified it in some way, collected that information. And what we're going to start learning today is going to be the next step in that process. But at the end of the semester, you would have done all the work. Theoretically, you would have already compiled your information, found the mean and standard deviation, answered 7 questions, figured out your sample size that you would need. You're going to be figuring out what your confidence interval will be with a certain level percentage. We're now going to start getting into what will be when we compare to figure out which is better or worse. And then next chapter, we're going to be able to say something a little more definitively. So your final in this class is going to be a compilation of everything that you've done. So as long as you've been doing your work as we go along, all you're going to be doing is pretty much copy and pasting and wordsmithing a few slides, and you're going to submit the slideshow to me. And during our final period, we're going to see all the work that everyone has done. Now, what's being asked of us, which I'm not planning on doing, is that they've asked us to break up the final into 2 parts. One's worth 10%, which would be some sort of test, and the other one is going to be some sort of reflection. Now, I don't really know what that entails. We're going to find out more tomorrow, and I'll let you know. But I wanted to ensure you that my plan that I'm going to stick to is going to be this virtual walkthrough, so you won't have to worry about anything else from me. Now, as for attending the final, it will be a virtual walkthrough. So if you weren't here, as long as you've submitted your work, that would kind of be fine for me. I was informed by Ms. McKillop that if you are a fully remote student, you do not have to come in for finals. So that is just kind of good to know for those that are fully remote. Those that are doing winter sports, I heard the school board is going to be voting tonight about the future of those. So we'll see about that. Otherwise, you're technically fully remote as well. And then we'll see if we even end up back in class. I know that conversation is going on. Cases are still on the rise. We still haven't seen the Christmas bump. So who knows what will happen? Sorry, the holiday bump. So anyway, that's kind of like what we know about finals and what we'll be doing. Um, and the expectation, as I said, so if you have any questions, please feel free to reach out to me. I do know that they're trying to do finals for 2 weeks so that one cohort will do the test 1 week and then the other cohort would be doing the reflection and then they'd be able to flip. But again, I don't really know everything that's going on. Hopefully I get more information about that tomorrow. Okay, so for the notes for today, it's just going to be a conceptual, do you understand? There's not going to be much, if any, math involved. So a nice little break for you guys. So we're going to be moving on to 8.5, which is estimating the difference between 2 population means. Now I did skip a section, don't worry about it. So in this section, we'll be comparing 2 populations with a certain level of confidence. We are going to be able to conclude one of 3 things. The first thing that we could conclude is that we could say that our first population is better, or it's higher, or it is something. So it is the more dominant number. So when comparing population 1 to population 2, I can say with a 95% level of confidence that population 1 will have more car accidents, will make more money, will be smarter, will grow higher, whatever it may be, population 1 would be our preference. The second outcome that may occur is that the second population is the better of the two. So it's better or it's higher or whatever it is that we're studying, population 2 has won our vote, and that is the one that we would go with over population 1. So we're strictly just comparing. Now, number 3 is if we statistically cannot conclude that one is better than the other. So either 1 is better, 2 is better, or we don't know. Now, the two different types of populations that we can have independent populations and we can have dependent populations. Now, independent populations are when we have two separate groups that we are comparing against each other. So they're both kind of happening at the same time, and we want to know which of the two groups is better. So for example, if I take a pencil and I write my name down with my left hand, and then I write it down with my right hand, and I time both of those, which one was faster? So maybe I'm faster writing my name left-handed. Maybe I'm faster right-handed. It's the same thing, but two separate groups, and I'm comparing between the two. Now, a dependent population is a before and after sort of situation. So back to my writing my name example, what if I were to write my name, time it out, and then I do some hand exercises. I lift some weights, I do that little squeezy thing, whatever I want. I do a bunch of hand exercises for a week. Then all jacked up, I grab that pencil again, and I write my name as many times as I can, as quickly as I can, whatever I'm doing. And then that's a before and after. I'm still writing my name with my left hand, but I've done something to alter the second population. And I'm going to ask, well, can I write my name faster if I do more hand exercises? Or was I writing my name faster without the hand exercises? Or does it not matter whether I do hand exercises or not because I write my name at the same speed? Now, how to know whether the first, the second is better or there's no difference? We're going to look at our confidence interval. Now, we're going to be calculating our confidence interval tomorrow. We're not going to be doing that today. Now, when you get your confidence interval, the actual numerical values don't matter. We'll talk about those later. What matters is whether or not they are positive or negative. Now, if we think about it, we are doing the difference of two means. Right here, I'm trying to figure out which one's better. So if I were to take a number and subtract a number from it, and I get a positive number back, that would mean that the first population was the better of the two, or the bigger of the two. 10 minus 8 is 2. So the bigger number dominates whether it's positive or negative. Now, if I create a confidence interval and my lowest number and my highest number of my confidence interval are both positive, then that means that even after adding and subtracting the margin of error, the first population was significantly larger to say that the difference of the two means, no matter what situation I'm in, the first one will be better. So if you get a confidence interval that's positive to positive when comparing two means, we can say that the first one is greater than the second one. Now, in number 2, this is when the second one is bigger, so the first one is smaller than the second one. That would be that if you had a number and you subtract another number from it and it produces a negative, that means that the second number had to have been the larger of the two numbers. 8 minus 10 is negative 2. So if your confidence interval is a negative number to a negative number, then that means that with the margin of error and your level of confidence, the second population had a larger value overall. How you would know if there was no statistical difference between the two populations? Well, if you had a value and you subtracted the margin of error and it gave you a negative value, but when you added the margin of error into a positive value, that means that the values between the two populations are so close that it goes both negative and positive. That's when you cannot statistically make a judgment as to which one is better. So we're going to go through this work tomorrow. We're going to figure out the confidence interval. We're not going to care about the actual numbers. We're only going to look if they are positive or negative numbers in the interval. Positive to positive, the first population's better. Negative to negative, the second population's better. Negative to positive, there is no statistical difference between the two. And if you're wondering, no, we're never going to have positive to negative because it's an interval and it doesn't make sense. It goes min to max, and a positive is always bigger than a negative. So you'll never have positive to negative. You will only have positive, positive, negative, negative, and negative to positive. So that's what we're talking about today. I'll throw a couple questions in the classroom, and that's what you can submit.